So this comes out to be the square root of 89, which is in fact 9.43. So she made a mistake. Let's find out where. All right, so click continue. Do you agree with Drea? Why or why not? So anything that says yes, I'm going to automatically just ignore, because no, I don't agree with her. We found that there was an error in finding the BD. So no, I don't agree with her proof. She did not correctly substitute the coordinates of the points when she found BD. Yes, that was exactly where we found the error. And then it explains it. Okay, so now we're going to jump down to example. Prove that a quadrilateral is a rhombus using the distance formula. Okay, given the quadrilateral ABCD with coordinates A, -2, -3, 2, B, 2, 3, C, 1, -2, D, -4, -3. Prove that ABCD is a rhombus. Okay, we can use the distance formula and the given coordinates A, -3, 2, B, 2, 3, C, 1, -2, and D, -4, -3 to find the lengths of each side. Which answer choices show the correct substitution in the distance formula for each side? Okay, I'm going to erase what we did from last step. I wonder. And then I'm going to draw a rough sketch again, because I am a very visual person and it helps me keep things straight. So here's my rough sketch. A is at -3, +2. A. B is at +2, up 3. So it's slightly higher than A on the Y. C is at 1, -2. And D is at -4, -3. So that is D. And they want me to prove that this thing that I drew is a rhombus, which means every single side length is the same. So I want to prove that from A to B is the same thing, the same distance from B to C, the same distance from D to C, and the same distance, or C to D, however you want to read it, and the same distance from A to D. So let's start by looking this over. Okay, there is more than one correct answer choice. Select all the correct answer choices. So A, B. So I'm looking at these coordinates. 2. So that means that this was x2. That means this is y2. And that this is x1 and y1 for this formula. So x2 minus x1 minus -3. So far so good. Plus y2, 3 minus y1, 2. Correct. So I'm clicking that one. So far that is correctly substituted. Okay, let's look at the next one. Alright, AB, -3. Okay, so they are using this one as x1, x2 now. y2, x1, y1. Okay, so let's check. x2, -3, minus x1, 2. So far, so good. Y2, 2 Yep. Minus y1, 3. Yes. So that is also correct. They just switched which one they started with first. Okay, now we're going to go to BC. BC. So let's start off. 2. I know in the formula that is designated as x2. So B, that is x2, y2, and this one would be x1, y1. Okay, so 2 minus a negative 2. Well, x1 is 1, so no, that one is not correct. So I'm skipping that one. BC. Again, in the formula, this is x2, so I'm going to label it x2. That's an x. x2, y2, x1, y1. Okay, so let's look. 2 minus x1. Yes, that is correctly replaced with x1. 3. Yes, that is y2. Or minus negative 2. Yes, y1 is negative 2. That was correctly substituted. All right, CD. We're going to start at negative 4. So they used D as x2, y2. This one would be x1, y1. So negative 4 minus 1. Yes, x1 is 1. Plus negative 3. Yes, y2 is negative 3. Minus negative 2. Yes, y1 is negative 2. So far, this one is correct. Okay, CD, negative 3. Well, this is supposed to be x2. So no, I do not agree with that one because negative 3 is a y value, not an x value. So I'm skipping that one. That one is not correct. AD. All right, negative 3. That is the x2 value. y2. And the reason I know that is x2 is because in the formula, the first thing written here is x2. So that is correct, x2. So then this must be x1, y1. So let's check this out. Negative 3 minus negative 4. Yes, negative 4 is x1. So then let's look. What is y2? y2 is 2. Check. Minus y1, negative 3. Yep, I agree with that statement. Okay, AD, negative 3. Well, it could be possible that they started with A instead. So, this would be x2, y2, x1, y1. Take that in the other room, sweetheart, real fast. Go watch it on the couch. Sorry, my daughter brought in her music. Okay, so let's check. Negative 3. Yes, that's x2. Minus y1 is a negative 4. So no, I don't agree with this because negative 4 is not the same thing as minus 4. So they forgot the negative sign. Okay, so that should be our answers. There we go. And then Okay, and then when we simplify each equation, we find that AB equals the square root of 26, BC is the square root of 26, CD equals the square root of 26, and AD equals the square root of 26. So then, by the substitution property of equality, we have that AB equals BC equals CD, which equals AD. Then AB is the length of AB, the segment AB, is congruent to the segment BC, which is congruent to the segment CD, which is congruent to the segment AD by the definition of congruent segments. Therefore, ABCD is a rhombus by the definition of rhombus. And that is how they would link these together. All right, there you have it.